Okay, welcome to a video for Math 2, Section 5.4 and 5.5. We're looking at special cases of parallelograms. So let's start with a review of what a parallelogram is. A parallelogram is a type of quadrilateral that has two pairs of opposite sides that are parallel. So to start with here, this would be a parallelogram right here at the top because we have two pairs of opposite sides that are parallel. That's by definition. There are other characteristics that we learned of that are true about parallelograms. Okay, so this is a parallelogram. By the way, I forgot to mention, this is a printable handout that you can find in the Math 2 documents folder. I would recommend that you print it so that you don't have to copy down as much in your notes. But if you can't print it, you can still get credit for this video by taking the notes. All right. So you can print these out. We can put them in your notebook later, but they're going to go on the next 2 pages. Specifically, let me check the checklist here. 68, but we don't need 4 pages, so just 68 and 69. So, going back to our notes here, this would be on page 69, and the examples page is going to be on page 68 of your interactive notebook. Okay, so that's a parallelogram. So now we're going to look at special parallelograms. So if you have a parallelogram that has 4 congruent angles, you have a rectangle. So the definition of a rectangle is it is a parallelogram. So that is part of the definition that has 4 congruent angles. Now we know that the sum of the angles of a quadrilateral, which a parallelogram is 360 degrees. So if all 4 angles are congruent, we can divide them by 4 and we get that each one is 90 degrees. So another way that you can say this is that it's a parallelogram that has 4 right angles. That would work as a definition as well. So this is a rectangle. Now a rectangle is going to have all of the characteristics that a parallelogram has. So you may want to review those. Okay, so like opposite angles are congruent, that's true. Consecutive angles are supplementary, that's true. Opposite sides congruent, diagonals bisect each other, all of that, okay? So this is the rectangle. That is your first special type of parallelogram. The next one we have is the rhombus, and plural for rhombus. You don't say rhombuses, well I guess you can, but you're going to hear rhombi. R-H-O-M-B-I. Is it like sort of cactus and cacti? You'd say the plural that way. Okay, so the definition of a rhombus, it is a parallelogram. So it is, whoa, parallelogram. That was weird. That has 4 congruent sides. Not angles this time, sides. So we know that the opposite sides are congruent in a parallelogram, but they're not all congruent. So when I say 4 congruent sides, we're saying all 4 are congruent. Now that doesn't mean it's a square, because the angles may not be right angles. It's more of a diamond shape. Okay, so here is our second special one, the rhombus. Okay, now if you have a rectangle and a rhombus at the same time, so in other words you have 4 congruent angles and 4 congruent sides at the same time, that is when you have a square. So a square is a very special shape. It is a parallelogram. it is a rectangle because all four angles are congruent, making them right angles, and all the sides are congruent because it's a rhombus. So this is one diagram that you often see to show this relationship. You can also do a more Venn diagram shape. So if I do a Venn diagram, everything in here is a parallelogram. Then everything in here would be a rhombus. And all rhombuses, or all rhombi, are parallelograms, so they are entirely contained. And then everything in here would be a rectangle. Again, that's completely contained within parallelograms. And then this overlapping section right here of rectangles plus rhombuses, those are your squares. I could barely fit the word in there, but so that's another way that you can represent it with a Venn diagram. So in your checklist, there are 3 links here for GeoGebra things that I want you to play around with first. So if you haven't already done so, pause the video. I want you to play around with this. So if you go to, make this a bit smaller so it fits, okay? If you go to the first one, this is a rectangle, and there's some check boxes there. There's just 2 things. You can look at the angles, they're all right angles, and you can look at the diagonals. And just try and figure out what's true about these things. So do that for rectangles, rhombi, and squares. Just play around with them a little bit. Okay, so when you're ready, you can unpause the video. So looking at a rhombus first, there are 2 things you should have noticed when you played around with it in the video. The first one is the diagonals do something very important. They bisect the angles. In fact, they bisect the opposite angles. Just a little note here, this name of the theorem is from an old book. That's not the number in the theorem from your book. It doesn't matter though, it's the same information. So what this is saying here is that, so we have a diagonal, AC is a diagonal. This angle over here and this angle over here are congruent to each other because this AC cut this angle right in half. Okay. And then this angle here would be congruent to this angle here. This angle here would be congruent to this angle here. In fact, these 4 angles, see if I can color them here. This angle, this angle, this angle, and this angle would all be congruent to each other. Because remember, the entire angle, angle ABC, is congruent to angle CDB, because opposite angles of a parallelogram are congruent. So if you cut them in half, then they're still congruent. They're just halves of them. Okay, and then these 4 little angles here would be congruent to each other. So that's what this one says. The diagonals bisect the angles. They also are perpendicular. So when they come together, they should be a right angle right there. So those are special characteristics of a rhombus, besides the characteristic that we learned in the definition. Okay, and there's one characteristic of a rectangle, and that is the diagonals of a rectangle are congruent to each other. So if you have a rectangle, the diagonal from here to here, its entire length will be the same as the diagonal from here to here. Now we also know the diagonals of a parallelogram bisect each other. Now in the case of a rectangle, all 4 pieces would be congruent, because let's say the whole thing here is 10. which means the whole thing here is 10. And since the parallelogram bisects the diagonals are bisecting each other, then all four pieces would be 5. Okay, now squares. Squares are just rectangles and rhombuses at the same time. They're not a new shape. We don't have a definition of a square really other than saying it's a rectangle and a rhombus at the same time. So they don't have any extra characteristics. So when it comes to squares, all we really say is because a square is a rectangle and a rhombus, it shares all of the characteristics of both of those shapes. It's also a parallelogram. Remember, all of these are parallelograms. So they all share the characteristics of parallelograms. Okay, so let's try some problems here. Let's do some examples. So the first one says the diagonals of a rectangle have lengths of 4 plus 2x and 6x minus 20. Find x and the length of each diagonal. Okay, well, we have a rectangle. The diagonals that they're telling us about are, so one is 4 plus 2x, maybe that's this one. And the other one is 6x minus 20, so maybe that's this one. Now we know the diagonals of a rectangle are congruent to each other. So anytime two things are congruent, we just set them equal. So 4 plus 2x is equal to 6x minus 20. So we need to solve for x. Let's get our x's onto the same side. Since we have a 2x and a 6x, I'm going to subtract 2x here. So I'm left with 4 equals 4x minus 20. Let's add 20 to both sides. That's 24 is equal to 4x. Divide both sides by 4. X is equal to 6. So that's x. X equals 6. The length of each diagonal, if we plug in x, so that's 4 plus 2 times 6, which is 4 plus 12, which is 16. Now, I don't really have to plug in the x again because I should get the same exact answer. They're congruent, right? But it's a good way to check to see if your x is correct. So let's plug it in for 6x minus 20. So 6 times 6 minus 20 is 36 minus 20, which is 16. It worked. They're congruent. Okay, let's look at number 2. Find the measures of the numbered angles in each rhombus. Okay, so remember that you have a special parallelogram, which means opposite angles are congruent. So I already know that the measure of angle 3 has to also be 56 degrees. Then the other thing, let's get a bright color here, orange, okay, is this whole angle, angle 1 and angle 2 added together, this whole angle plus this angle have to add up to 180. They have to be supplementary. So if I do 180, take away the 56, excuse me, that's going to be 124 degrees. That's what angle 1 and angle 2 have to add up to. But I need each angle, angle 1 and angle 2. So remember that in a rhombus, which they told us this is, the opposite angles are bisected by the diagonals, which means angle 1 and angle 2 are equal, they're congruent. So I'm just going to take this 124 and cut it in half. That gives me 62 degrees. So that's what each of those angles has to equal. Okay, so number 3 is a rhombus as well. Alright, so the first angle that I'm going to answer is angle 1. Angle 1 is where the two diagonals come together. And we said the diagonals of a rhombus are perpendicular. So that means the measure of angle 1 has to be 90 degrees. That's an easy one. Then this angle here is 70. This is going to be a right angle. We can figure out this angle, the one that's next to angle 2. Basically, the 70 and this angle, I'll call it x, are going to be complementary. Remember that means they add up to 90. I could, I don't want to, I mean, I could say that if this is 70, this is, x, I could just add them all up and set them equal to 180. But in a right triangle, the two angles that are not the right angle would be complementary. They'd add up to 90. And that's because you could just take that right angle away, the 90 away from 180. Just a shortcut. So complementary, 70 and 20 add up to 90, so that's x. And remember that in a rhombus, these angles right here would be congruent. So that gives me angle 2 is 20. And it also means angle 3 is 20. Because remember I told you that these four angles would all be the same. And also, these four angles would also be the same, which gives me my last angle here, which is the measure of angle 4 would be 70. You can also get that this is 70 because you have parallel lines, and those are alternate interior angles. Okay, last two. Determine whether the quadrilateral can be a parallelogram. If not, write impossible. Explain. Let's see. So each diagonal is 15 centimeters long. Okay, so each diagonal is 15 centimeters long, and one angle of the quadrilateral is 45 degrees. Well, if each diagonal is 15 centimeters wrong, doesn't that mean that the diagonals are congruent? Okay, well that's only true if it is a rectangle. And if it's a rectangle, then all the angles are 90. So how can one of the angles be 45? That's not possible. So this is an example of an impossible case. Okay, let's look at the second one. The diagonals are congruent, perpendicular, and bisect each other. Okay, if the diagonals are congruent, that means it is a rectangle. If the diagonals are perpendicular, that means it is a rhombus. If the diagonals bisect each other, that means it is a parallelogram. If it's all three, it's a square. So it didn't ask me what it is, but let's write down this is a square, and a square is a parallelogram. So the answer is yes, it is a parallelogram. Okay, that's it for these notes. Your homework is on Math Excel as usual. I'll see you guys next week.